This is a reteach of Standard 1, which is identifying functions from a table. We'll be looking at linear, quadratic, exponential, or functions that don't fall in any of those three categories that we're studying right now. You want to have your function flowchart handy. I will be referring to that, but you want to have this out when you're reviewing and taking your retest. So we'll look at several examples together. Always, the number one thing that you do when you are looking at a table and trying to determine which function it is you start at the beginning of our flow chart or decision chart. So the first thing we're going to do is we're going to look at our table of values and we're going to follow the arrow, and it says, is the change of x constant and is the change of y constant? That's the first thing we're always going to do. And remember to pause the video and try these for your own. So if I'm going to look at the change in x, I'm going to see what is that change in x as I go from here to here on down my table. So from -2 to -1 is an increase of 1, -1 to 0 is 1, all the way down my table. My change in x is 1, so that is constant. When I look at my change in y, from 1 to 3 is increasing by 2. From 3 to 9 is increasing by 6. From 9 to 27 is increasing by 18. And from 27 to 81 is increasing by 54. So this is not constant. And my change in x was constant. So let's look back at our flow chart to see what that tells us. So change in x is constant, that's a yes. Change in y is constant, that's a no. So I'm not going down here. If they're not both true, we're going to go here. Now it says, does the change in y over the change in x always simplify to the same constant? So if I want to look at the rate of change, I would be looking at the change in y over the change in x, and I would see that I get 2 over 1 for my first set, I would get 6 over 1, I would get 18 over 1, and I would get 54 over 1 if I'm comparing each of these values, each of these changes along the way. These are not the same. 2 does not equal 6, which does not equal 18, which does not equal 54. So I know that this is not a linear function. What does that tell me to do in my table? So if the rate of change is not constant, then I keep going. Is the change in x constant? And when I look here, those are all ones that is constant. So now we're going to think, how are the y values changing? And the first thing, if we follow our arrow, says, is the second difference constant? So I'm going to look to see at my table, is my second difference constant? So I'm going to go back over to my y values, and I'm going to look here. This difference from 2 to 6 is increasing by 4. From 6 to 18 is increasing by 12. And from 18 to 36, or to 18 to 54, is increasing by 36. So my second difference is not constant. That tells me that this is not quadratic. If I look back in my table, and I can put a little arrow there so you can see where we are talking about this. So my second difference is not constant. If it had been a yes, then it would be quadratic and I would be done. It is not. So now I want to see, is the change in y increasing or decreasing by a factor or a multiplier? In other words, do I see multiplication between values? And when I look at this, I can see multiplication in a variety of ways. I can see from 3 to 4, from 4 to 12 is multiplied by 3, and from 12 to 36 is multiplied by 3. I can see that from here, from 2 to 6 is multiplied by 3, from 3 to 18 is multiplied by 3, and from 18 to 54 is multiplied by 3. And I can also see it in the actual y values. To go from here, 1 to 3 is multiplied by 3, from 3 to 9, 3 times 9, 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So this is a multiply by 3 to get to the next term. This tells me that this is an exponential function. And we are done with identifying for that. This is not considered a constant rate of change because it is multiplication, just to point that out there. Now let's take a look at this second example. Again, no matter what you're doing when you're trying to identify the table, you're always going to start at the start of the chart and then ask yourself, is the change in X and the change of Y constant? Are they both constant? And so I'm going to start like I did on the example before and look at 5 plus 1 is 6, 6 plus 1 is 7, 7 plus 1 is 8, 8 plus 1 is 9. So my change in X is constant. I'm just going to put a note there so we can remember that. Now I'm going to look at my change in Y. As I go from -1 to 4, you can look at this on a number line to think about that. As you go from -1 to 4, that's 1, 2, 3, 4, 5 units to the right. So that's an increase of 5. From 4 to 9 is an increase of 5. From 9 to 14 is an increase of 5. And from 14 to 19 is an increase of 5. This is also constant. So if I consult my flow chart, you can see that is my change of X constant? The answer was yes. They all went up by 1. And is my change in Y constant? Yes, they all went up by 5. So this is a yes. So that means I have a linear function and I am finished. Let's take a look at example 3. And again, we will always start with the table of values, looking at the change in Y and the change in X. So from -7 to -6, if you want to look at a number line, -7 to -6 is increasing by 1, -6 to -5 is increasing by 1, and so on. So in this table, our X values are all increasing by 1, so our change in X, we can say, is constant. I'm going to do the same thing for Y's, looking at our change in Y. 5 to 2 is decreasing by 3. From 2 to -1, again, from 2 to -1 is decreasing by 3 spots, so decreasing by 3. And then from -1 back to 2 is increasing by 3. And from 2 to 5 is also increasing by 3. So we have all 3's, but some are increasing and some are decreasing. So this is not constant. So let's take a look at our flow chart. So change in Y and change of X is not constant. So we have to look here. And then we'd look, is the change in y over the change in r, that ratio or the rate of change, does it always simplify to the same value, which is a constant? So if I think of the rate of change as being the change in y over the change in x, all of my x values are the same and my y values have two different values. So my rate of change is either going to be -3 or 3, which is not the same. So my rate of change is not always simplified to the same constant. So that's a no. Then we look at, is the change in y constant? And that answer is yes, it was 1. So we're going to start looking at how do our y values change. So now we need to look at the second difference. And if I look here at my second difference, the difference between -3 and -3 is 0, but the difference between -3 and +3 is 1, 2, 3, 4, 5, 6. So this is an increase of 6. The change between 3 and 3 is also 0. So our second difference is not constant. So this means that it is not quadratic. So we know it is not linear and it is not quadratic. So going back to our flow chart, is the second difference constant? No. Then we're going to look at, is the change in y increasing or decreasing by a multiple? Is there multiplication as we go from here? And there is, if I look at from 3 to -1, you can multiply by 1, but 1 times -3 does not give you 3. So the change in y is not a difference. And if you look from 5 to 2 to -1, there's no common multiplier here as well. So you could say no multiplier means not exponential. And you could divide successive. So I could take 5 divided by 2 and see that that's a different quotient than 2 divided by -1 or -1 divided by 2. So since there's not the same multiplier, it is not exponential. And at this point on our flow chart, if it's a no, it tells us that this is none of the functions that we're studying. So this is a none of the functions we're studying. Okay, let's take a look at this last example. Again, we're going to start by doing the same thing. Change in x from 11 to 14 is an increase of 3. From 14 to 17 is an increase of 3. 17 to 20 is an increase of 3, and 20 to 23. So my change in y, even though it's not 1, is still constant because it's going up by the same amount. And then if I look at my change in y, from 9 to 13 is a decrease of 4. From 9 to 5 is a decrease of 4. From 5 to 1 is a decrease of 4. So all of these are a decrease of 4. So let's look at our flow chart. So this is also constant. So if I look at my flow chart, is the change in x constant? That was a yes. Is the change of y constant? That was a yes. I know right away, I don't need to do anything else. This is linear. And that is what that function is.